My name is Alex Galt. I'm a math teacher at Edina High School. This lesson is about using function notation in the real world, and by the end of today, you should be able to understand and use function notation with real-world situations, whether the function is presented to you as an equation, a table, or a graph. Okay, the first example problem. The function t of x, shown below, represents the surface temperature T in degrees Celsius at latitude x. Use the graph to estimate the following outputs. T of 40. So that means that my x-coordinate is 40. So on the graph I go to latitude of 40. And then I'm going to read what the y-coordinate is at that point. It looks like it's about maybe 16 degrees. And then t of negative 70. Negative 70 is my x-coordinate, so I'm going to look for negative 70, and I'll read the y-coordinate at that point. It looks like it's about negative 1.5. Hawaii has a latitude of 20. What would you estimate is the average temperature of Hawaii's sea surface? So if the latitude is 20, latitude is the x-coordinate, so I'm going to go to 20 on the x, the latitude, and I'm going to read the y-coordinate at 20, and it looks like it's about 26. T of negative 34 is a math sentence about Sydney, Australia. What does the math sentence mean in terms of sea temperature and latitude? So the negative 34 is the x-coordinate, which means that's the latitude of Sydney. And the 18 is the y-coordinate, which means that it's the temperature in degrees Celsius. So at negative 34 degrees latitude, sea temperature is 18. It's important to understand how to translate the real-world sentence into the math language of t of negative 34 equals 18. So this problem, the function b of t, shown below, represents the internal temperature B in degrees Fahrenheit of a brisket, which is a kind of meat, T hours after it was placed in the smoker. So T is the x-axis, that's hours, and B is the internal temperature of the brisket. Use the graph to estimate the following outputs. B of 2. So B of 2 means 2 hours, and I want to estimate the temperature at that point. It looks like between 130 and 150, maybe 145, maybe 140, a little bit less than 140 maybe. B of 10 means 10 hours after it was placed in the smoker. The temperature is almost 190, maybe 185 degrees. What was the temperature of the brisket when it went in the oven? So when it went in the oven, that's going to be at T equals 0. So I'm going to look for T equals 0. It looks like the temperature was maybe 35 degrees, perhaps. B of 6 equals 153 is a math sentence about this brisket. What does it mean for the brisket? Well, 6 is the x-coordinate, and the x-coordinate is hours. So 6 hours after it goes in the oven, the temperature is 153. Okay, the next section. The function h of t shown below represents the average circumference h of female babies' heads in centimeters when they are t months old. Use the table to estimate the following outputs. H of 3 equals, well, h of 3 would be 40 because that's in the table. H of 9 would be 44. What's the average head circumference of a newborn baby girl? So newborn would be T equals 0 months old. So T equals 0 months old, that would be 34.8 centimeters. Explain why h of 10 equals 43.2 doesn't make sense for this function. 10-month-old babies can't have smaller heads than 9-month-old babies. So 9-month-old baby has a 44.0 circumference head, so a 10-month-old can't have a smaller head than a 9-month-old. Well, one could, but the average couldn't. Section 4, the function w of t represents the temperature in degrees Fahrenheit in a tub t minutes after it begins being heated. W of 4 equals 57.1. W of 20 equals 71.0. If the temperature of the water in a tub is 58 degrees, estimate how many minutes it has been since it started being heated up. So 58 degrees is somewhere in here. I would accept any answer between 4 and 9, maybe 6 minutes. W of 9 equals 61.8 is a math sentence about this function. What does it mean for the tub of water? It means that 9 minutes after it was heated, the tub is 61.8 degrees. Section 5, the function f of c equals 9/5 c plus 32 can be used to convert a temperature, C, in Celsius to a temperature in Fahrenheit. So f of 10 would be 9/5 times 10 plus 32. And a reminder about multiplying fractions, you don't need to find a common denominator, but sometimes it's helpful to have a denominator. You multiply straight across, so you'd have 90 divided by 5 plus 32. Order of operations says we divide by 5 first, so that'd be 18 plus 32, so that'd be 50 degrees. And f of 100 would be 9/5 times 100 plus 32. So 900 divided by 5, or 180 plus 32, or 212. This is actually a fact that a lot of people have memorized, is that 100 degrees means boiling water in Celsius, and 212 degrees means boiling water in Fahrenheit. F of c equals 32. What is c? So for this one, we're going to go backwards. So f of c is 32. That means that the y-coordinate is 32. So we do 32 equals 9/5 c plus 32. To solve for c, we would first subtract 32. So we have 0 equals 9/5 times c. I know we have to divide by 9/5, but 0 divided by anything is going to be 0. This is another fact that some people have memorized, that 32 degrees is when water freezes in Fahrenheit, and 0 degrees is the equivalent temperature in Celsius. F of 25 equals 77 is a math sentence about this function. What does it mean for temperature? 25 degrees Celsius is 77 degrees Fahrenheit. That's room temperature. Okay. This lesson was about using functions in the real world. I hope you have had some comfort with using equations, tables, and graphs.